Hello, I'm Jash. In this video, I will be designing a mat foundation for the tall building which I prepared in the previous video. The column layout at the base of the tall building is shown here. The safe bearing capacity of the soil is 300 kN per meter square and the allowable settlement is 1 centimeter. The column dimensions and the dead loads and the live loads, that is the axial forces of the columns, are mentioned here, and the materials by which the columns are constructed is also mentioned as shown here. This is the list of columns which we will going to use. The subgrade modulus is equal to safe bearing capacity of soil by allowable settlement. Thus the subgrade modulus which we get is 3 into 10 raised to 4 kilonewton per meter cube. The column strip width is 0.25 of the smallest length. Here both the length and breadth are 18 meter, so 0.25 into 18 is 4.5. Thus the strip width we get is 4.5 meter, but for the purpose of accuracy we will construct the column strip width of 4 meter only. So let's start in safe software. We will create a new model, set the design code to IS-456-2000. In design preferences, we will change the clear cover which is 50 mm for foundations. Here we will take the preferred bar sizes as 22 mm. Click on OK. The units are metric, so it is good. Now we will select grid only. Here we will take the uh, here we have the length is 18 meter and the breadth is 18 meter. So the total dimensions in both x and y directions are 18 meter. So if we take the grid spacing as 1 meter, then we will require the 19 grid lines in both x and y direction. So here in number of grid lines we will write 19 in both the x and y directions, and the grid spacing we will mention as 1 meter each. Click on OK. So the grid has been assigned. Now we will define the materials. First we will define the concrete material, that is the M40 concrete. Here we will select concrete. Here we write its properties. Its compressive strength is 40 Newton per mm square. Click on OK. Now we'll add another material, that is the rebar material HYSD 500. Its yield stress is 500, thus it is named HYSD 500. The yield stress is minimum. Now as we have defined the materials, we'll click on OK. Now we will define the slab, that is the footing. Give the name as mat footing. Give the slab material as M40. Give the slab thickness as 500 mm. Select a type as mat. Now click on OK. Now we will define the column sections. In column properties, click on add new material. Give the name as column of size 500 into 500 mm. Material as M40. Okay, now we'll add a copy of this material. That will be column of size 600 into 600 mm. Material is M40. Size is 600 into 600 mm. Click on OK. We have defined the columns. Okay, now we have defined the columns also. Now we'll check the load patterns, load cases, linear static, load combinations. We will add the load combinations. For first, we will add for the ultimate strength, that is the dead load into 1.5 and the live load into 1.5, and here we will select ultimate strength. Click on OK. We will add another combination, dead load into 1 and live load into 1 for service strength. Okay. Now we will draw the slab footing, mat footing. Here select the property as mat footing and now draw the slab. Now we will expand this slab by 2 meter in both the directions. First we will select the slab. One area 4 edges selected. Click on edit, edit areas, expand shrink areas, offset value. We will expand by 2 meters, so 2 meters is equal to 2000 mm. So here we will add 2000. Click on OK. Now we will draw the columns. Column property below none. Column property above 500 into 500. Height below 0. Height above 2 meter. Okay, now we will draw the columns. Each spaced 6 meter away from each other. These are the columns of 500 into 500 mm size. Now we will draw the columns of 600 into 600 mm size. Column property above is 600 into 600. Height above is 2 meter. Okay, so we have drawn all the columns. We will delete this column. Okay. Now we will draw the design strips, which we have got as 4 meter by the calculations. 4 meter, 4 meter, 4 meter, 4 meter. And now we draw the design strips. It should pass from the center of the columns. Now we have drawn the design strips in X direction. Now we draw the design strips in Y direction. We'll give its name as strip layer B. It is not properly drawn, so we will select it and delete it. Now we'll draw the design strip B. Okay, so now I have drawn all the design strips in both X and Y directions. We can see the design strips by clicking on these options and clicking on OK. Now here we can see all the design strips in both the directions. Okay, now we will change the material property. Okay, I have not defined the soil subgrade properties, so first we will define this. Here we have got the subgrade value as 3 into 10 raised to 4 kilonewton per meter square. So here we will write that particular value and click on OK. Click on OK. Now we will assign that to our footing. So select the area of footing and then click on assign. Click on support data, soil properties, soil 1, click on OK. Now it has been assigned. Now we will check the reinforcement of the footing. Assign it to HYSD 500 and click on OK. Now we'll change the reinforcement in the design strips one by one. Okay, now we no need to change the reinforcement in the columns as we have already assigned the reinforcement as HYSD 500 in the columns, but we can check by right clicking on the column. Here we can see that it is HYSD 500, so click on OK. Okay, now we will assign the loads on the columns one by one. So select this column, go to assign, load data, point loads. For column 1, the dead load is 1850. The dimension is 500 mm. Okay. I will assign the go to select, get previous selection, go to assign, load data point loads, live loads 797.6. Okay. So you have assigned data in live load to one C1 column. By the same way, we will assign loads to other columns. We have given loads to up till column 1 to column 5. Now the column 6 is the column having area of 600 into 600. So we will give the loads to the columns of area 600 into 600 afterwards. So first we will give the loads only to the columns of area 500 into 500. Okay, so we will continue further. Now we are assigning loads to the columns having size 600 into 600 mm. Here we should change the area to 600 into 600 mm. Now the column C7. Okay, we have selected design strip by mistake. Now we will apply loads on assign loads to the column number 10. Dead load is 5154.6. And live load is 2644. Now last column to assign load, that is column number 11 C11. Dead load on C11 is 5191.3 and live load is 2709.1. Okay. Now we can verify the loads in all columns by right clicking on the center of the column. Okay. Now we will run the analysis. First we will need to save the file. So this is the analysis result. Now we will check the punching shear design ratio. For that we will need to run the design. So we will first run the analysis and design. Then we will display the punching shear ratio. Here the punching shear ratio is much more than 1. Here the values are in the range of 2 to 4. So for that we will change the thickness of the footing by unlocking the model, going to define, going to select properties, mat footing, modify property. We will give the thickness as 800 mm. Okay. Now we'll again run the analysis and design, and we click on display show punching shear design. Here again the punching shear ratio is more than 1. So we'll unlock the model, we'll go to define, we'll go to slab properties, mat footing, modify show property. Here we will write the thickness as 1200 mm and click on OK. Click on OK. Again we will run analysis and design, and we will check the punching shear design. Now we get the punching shear design of almost all the columns which is less than 1. So now all the columns have passed the design check. Now we will check the shear failure by going to display, clicking on show tables, clicking on flexural and shear data and clicking on OK. The table will open. Here the status in all the members is OK. So we can say that the footing has passed the flexure and shear data test. We can check the deform shapes under different load combinations and load cases here. We can also see the maximum bending moment diagrams and shear diagrams. We can also see the strip forces along the strips, that is the moment diagram along the layers, and we can also see the shear force diagrams for the combinations. Okay, now we can also see the crack widths. Click on apply. This is the bottom face crack widths. You can see on the top face by clicking on slab top face and then clicking on apply. These are the crack widths. These are in the of the value of 10 raised to minus 3 mm, which is a very small value. So these cracks can be neglected on site. We can see its value for different load combinations and load cases as shown here. Now click on close. Now we run detailing. Select all the 3 options and click on OK. This is the frame layout for the mat footing. As my safe software is an evaluation version, so it is not working well. Okay, it worked. This is the rebar plan for top and bottom rebars. This is the top rebar plane, this is the bottom rebar plane. Here in this rebar plane all the bars are shown. This is the section 1 and section 2 shown in the framing plan, which shows the minute details of the reinforcements with values. Okay, so we have completed the design of the mat foundation for a 23-story tall building. Thank you.